Hello and welcome to the Actuarial Raster channel, the channel where we break down actuarial exam questions step by step so you can answer them accurately and on time. In this series, we are still working on utility theorem, and today we'll be looking at September 2021 exam. In this exam, there are two questions on utility theory, question 1 and the very last question, question 11, carrying a total of 18 marks. So this goes to show you how important it is to master this question. So we'll just read the question. Question 1. An investor makes decisions using the utility function. We've been given the utility function there, which is log of wealth. The investor is going to invest 100. So this is the initial wealth, which is the investor is going to invest now for a period of 1 year and has identified the following two assets. So there's asset A, which is risk-free and will not change in value over the year. And then there's asset B, which will increase in value by 50% over the year with a probability of 0.6, or decrease in value by 50% over the year with a probability of 0.4. The investor does not make any allowance for discounting when making investment decisions. They are going to invest a proportion X of their wealth in asset A and the remaining 1 minus X in asset B. So here ideally we are combining two assets, asset A and asset B, and then we have been given proportions of asset A. So X goes to asset A and 1 minus X goes to asset B. So the first question is asking construct a formula in terms of X for their expected utility at the end of the year. So we have first to find the wealth if the investment goes up and the wealth if the investment goes down. So I'll just start from there. So the wealth if it goes up, or wealth if it goes down. So if it goes up, uh, X is being invested in asset A. So X of 100 is being invested in asset A, and then the remaining, which is 1 minus X, is being invested in asset B, 1 minus X of 100. But if it goes up by 50%. So we'll multiply by 1.5. We'll follow the same logic for if it goes down. So X is being invested in asset A. Then the remaining 1 minus X is being invested in asset B. So 1 minus X of 100. But in our case, the investment will decrease by, in this case, the investment will decrease by 0.5. So that is the wealth if it goes up or down. So the expected utility of wealth, will be the probability multiplied by the utility of wealth in both cases. So if it goes up with a probability of 0.6, and the utility of wealth is given by log W. So we'll just write log, and then if it goes up, let's simplify this. This will be 100x, and then will be 150 minus 50x, right? And then this will be 100. No, this will be 50 plus 50x. So 0.6, this is the probability of going up times the utility for going up, which is 150 plus 50x plus 0.4, the probability of going down, multiplied by the utility of going down, 50 plus 50x. So with that, we're done with the first part, and we get our 2 marks. And then now part 2. Part 2 is asking us to determine, using the results we obtained in part 1, the amount the investor should invest in each asset to maximize their expected utility. So ideally, what this question is asking is, it is asking us to find the value of x. So how do we find this value of x? By differentiating the expected utility of x with respect of utility of wealth with respect to x. So we'll just do that. So this becomes 0.6 multiplied by minus 50 divided by 150 minus 50x plus 0.4 multiplied by 50 divided by 50 plus 50x. That's correct. Then from there we have to equate this to 0. So this becomes 0.6. So we'll just move this this part, the first part, to over the equal sign, and it will make it positive. So we'll have 0.6, and then the 50 is on top will cancel, so we'll just have 0.6 divided by 150 minus 50x is equals to 0.4 divided by 50 plus 50x. Correct. Then we just go on to solve for x. We have 0.6 into 50 plus 50x is equals to 0.4 cross multiplying 0.4 multiplied by 150 minus 50x. So this is 30, yes, plus 30x is equals to, this is 60 minus 20x. Correct. So solving for this, we get the value of x to be 0.6. So the investor should invest 60, which is 0.6 times 100 in asset A, and of course 60 minus 100 minus 60, which is 40, and 40 in asset B. But we are not done with this question. Since it is a maximizing question, it's about maximizing, we have to show that this is a maximum. So to show maximum, we have to do the second derivative. So E, sorry, let's just start over. D squared E divided by dx squared. Correct. Okay, so I'll just copy this and write it here again, so it's easier for me to solve. Let me just rewrite it. 0.6 minus 50 into 150 minus 50x. This I will raise to minus 1 plus 0.4 into 50, and then multiplied by 50 plus 50x. This again is raised to minus 1. So obtaining the second derivative, I'll get 0.6 into minus 50. The derivative again, there is minus 50, but I have minus 1 here, so this minus 50 and this minus 1 will cancel out to be, I'll just have the 50, 150 minus 50x plus 0.4 into 50. The derivative here is plus 50, but then I have minus 1 here, so it will be minus 50 again, and then 50 plus 50x, this will be raised to minus 2. We forgot to raise this to minus 2. So, and as you can see that both of them are negative values, this and this, they'll give you a negative number which is less than 0, and this shows that it is a maximum. And with that, you are able to earn all your 7 marks. This is the Actuarial Rasa channel. Subscribe and join me as we tackle more actuarial exam questions together. See you in the next video.